Today, I'm going to talk to you about Inertia.js, GraphQL, Tailwind CSS, a bit about VueJS, and sort of how it all works in the ecosystem of either one of the two major MVC frameworks, either Ruby or on Rails, if you're a Ruby developer, or Laravel if you're a PHP developer. So what is Inertia.js? Inertia.js is essentially a library, a JavaScript library that binds with your backend, either Ruby or PHP. It will sort of allow you to bind communication between your backend and front end. And it allows you, the whole idea is it gives you that flexibility of if you can choose your backend, so you're not sort of forced to only use Ruby. You can use Laravel or vice versa. It also gives you flexibility of using multiple different front-end frameworks. So today I'm going to be presenting some of my code examples and things like that. They're going to be based on VueJS, just because I was experimenting with it and I wanted to find out more about how it compares to React. So I will be able to give you more of a feedback around, as I know most of us are at Kyan are React-based devs. But the idea for Inertia.js is that it allows you to choose that front-end frameworks whenever it's Vue. It can be React, it can be something else, for example, Svelte, and a bunch of others. But probably those are the 2-3 major ones that cover. GraphQL, essentially GraphQL is this fairly new bit of library, or essentially it's a language in its own right for data querying. So if I sort of give you a quick overview, step by step. So if we dive a bit more in depth into what Inertia.js is, the simplest way I can sort of navigate the idea of Inertia.js is that it is very similar to what Next.js does. If you're familiar with Next.js, if you're not, essentially Next.js is JavaScript only platform for you to set up essentially a fully fledged website. It offers you an API endpoints building, it offers you server-side and client-side rendering. So it kind of buckles up all those bits to create the environment for you to start building fully fledged websites. But it doesn't necessarily rely on the MVC structure, and it's only JavaScript based. And the takeaway where sort of Inertia.js comes in place is that if you're not 100% JavaScript developer, or you work with Ruby only in the past, but you're interested in the front end frameworks and you want to give it a try, but you're this backend person, Inertia.js is sort of a bridge between those two worlds. And I think it sort of fits its space where if you don't want to go full on JavaScript and, for example, just Next.js to build your website, that's a second option for you, where you can, if you're familiar with Ruby on Rails, you can do it with Inertia, or if you're a PHP, you can do it, for example, with Laravel. So that's sort of where Inertia sits in that sort of spectrum of what it offers. Now, the way Inertia.js people advertise themselves is they sort of say that it's a single page application building library without the API. So the way they sort of talk about it is that it almost as if API was a bad thing. And we all know that it might not be the case. APIs are actually fantastic. And one of the key elements here to take away is that Inertia, when you use Inertia.js, you don't have to build API. Essentially, it binds directly with your models. So if you have an entity, a database table called users, a model that reflects the user structure and any sort of relationships for that table with other entities and tables, all that is packed up, and Inertia allows you to bridge that model to view bindings. leveraging one of the front-end frameworks, which I think is fantastic, and it's a great tool. I think the key advantage of Inertia.js above everything else is that it's sort of the tool that allows you to get that the minimal valuable product out very quickly, because it's, you know, it allows you to base your backend on Ruby on Rails. You have the ecosystem of all the Ruby gems, all of the libraries that are available. That it might not be the case if you go only JavaScript way, where, I mean, npm packages are huge and most of the stuff you can do, but again, it's based on how you want your project to evolve, and the pure JavaScript option might not be the case for you, because you know, the experience of your team, your own experience, and you know, the sort of the plan for the website and project itself, and how you want it to evolve. I think the key takeaway for Inertia is that it allows you to use the backend and leverage all that it offers in terms of, if it's the packages for Laravel or gems for Ruby. It doesn't stop you from using API. So you can essentially create API endpoints, but it's not required for you to consume. It's essentially you don't have to go headless. So it's all buckled up in one application. Some of the advantages of that approach, as opposed to headless, is that you have essentially two separate applications and you're running a HTTP request to each one of the endpoints to request or commit data. And if you're building, for example, a minimal website that you want to demonstrate, or you want to test something, or the whole idea of having the two separate applications that you have to maintain, or even the limitation of having the HTTP traffic, or whenever it's over the network or over the internet, you might have some limitations, and it might not be ideal for you. And I think this is where Inertia essentially shines, because it allows you to buckle up all of those features into one app, and prevent from that extra request flying around the network. Second thing is GraphQL. As I said, it's a language. It's a language for data query API. It's ideal for APIs essentially, and I will demonstrate why in a bit. And as well, it's for mutations. So mutations is a bit of a fancy word here, but essentially it's anything that changes the data. So create, edit, delete. Few things around GraphQL. Well, it offers things like, it offers, the key takeaway from GraphQL is that you define the schema and define all the types. And when you query the data, you essentially specify the interface that you're going to be querying it with, and it buckles up with the response query, essentially one-to-one. Again, I will show an example in a bit, and a few other things that go over it. I guess if I jump to the next slide here. So the key element of how InertiaJS works, essentially, the first request is server-side, so it just serves you the full response, HTML response with everything in it. Subsequent requests are essentially a JSON response from the server, and depending on which front-end framework you use, it will utilize that. So if we're using React, it's just going to receive the components that updated. And it's going to update those components only. So it will leverage the virtual DOM. Same goes for VueJS, with few differences obviously between those two frameworks, but that's essentially how it works. It offers you the fully fledged SPA implementation on it. The key interesting thing when we use InertiaJS is that, well, essentially because it's based on Ruby on Rails, so you have your standard MVC structure. Every URL is going to would, for example, go to a particular route or endpoint you create in Rails, or vice versa in Laravel. The way Inertia handles all of the URLs is essentially they are canceled out using the libraries logic. So all of the links are essentially built on the inertia link component. And all of those URLs essentially then are made XHR request, which is then translated by Inertia into the, to communicate with the Rails, your Rails or Laravel backend. So it will translate to a specific route and do all its magic with all the models and relationships. So it will go normally through your route file, controller, and all the rest of the logic that happens there. Key thing around GraphQL. Well, I think essentially the key takeaway from GraphQL is that everything in it is fully defined. And let me show you some examples so I can sort of go through it and start explaining how it works. Can I? Okay, cool. So we have few things such as mutations. So when you make a request to an API, which is this basic example where I can create a user, I specify fully what create user function or procedure is going to be doing. In this case, it's going to be accepting a specific input variable, and it should contain, it should essentially contain name and email and ID, but this is the response that I should be receiving. The input requires, and this is defined in type, which I should be able to show you over here. Perfect. So my user is buckled up with essentially with model, which I can show as well in a second. But the user as an entity contains few fields, which is ID, name, email, created out, updated out, just to keep track of, and it changes to it. And as well, the user has a relationship with tasks. So I have this very simple database example where we can create tasks and users here. Just if I open my my VS Code, I can quickly show how it looks in terms of model perspective. So this is my example Laravel model, which specifies which fields are fillable. So it's essentially very similar to if we were to set it up in Rails, we would have the whitelist as well. And as well, we have a relationship which has many to the task based on the task ID. So if I come back here, what I can do is I can, if I were to make the request and pass fields such as name, email, and password, which are three required fields to create a new user, this is the mutation I would use. So this is essentially the GraphQL, and in the essence, any sort of response that I would want, I can essentially give the schema directly to the API. So if I don't want to query email, I would not specify email here. If I want more data out of it, I can add extra fields. So if I run this, that's your JSON response that you receive from the API endpoint. So it's end-to-end defining everything that should go in and everything that goes back. And sort of the greatest thing about GraphQL in this case is that you do not have something called, well, the idea of overfetching. So most of the REST APIs nowadays are, they offer you an endpoint to create an entry or query an entry. And usually they will just, spit the whole data structure at you. So if your table had, and if your endpoint was exposing, a user table, and your user table has 50 fields, by default, you would probably be getting 50 fields. But depending on what you're doing and how your application consumes that API, it's at the same time, it can be a huge disadvantage because there is a lot of data traveling over the HTTP that's just simply unnecessary. So this is essentially where GraphQL is shining in terms of implementations for any type of API, where you give essentially anyone who consumes your API, you give them ability to interact with the API endpoints, find out how API endpoints work, and at the same time have full control over the responses, or essentially have option of what the response is going to be like for them. So they only get what they need rather than everything. That's the sort of the key takeaway from GraphQL. I have a few other things I guess I could talk about. So here's a basic example of a relationship creation. So the syntax is telling us, I would make a request to the API endpoint, which gives it name, description, status, and user. And user is an object that has essentially a keyword called connected, which is 1. And in this case, I'm saying that I will create the task, and I will assign this task a user with ID of 1. So if I run this, here is an example of what the response would look like from the API. The relationship is that I can as well query in depth the user data. So again, because of my model restrictions, I wouldn't, for example, be able to query password because it's not within the accessible fields, but all the others. So if, for example, if I don't care about the email for that user, I just want the ID because that's what my application that I'm building based on this API is using, I would just specify ID and the response would be only that. So yeah, that's sort of, what else can I talk about here? I guess, I guess if I open schema and talk a bit more about how it's structured and how it all buckles up together. So it's going to be slightly different, and I use the Laravel in this example rather than Rails, just because this implementation called Lighthouse, this small library for Laravel, it buckles up the GraphQL language extremely closely. So it's almost everything you see in this file is native GraphQL. The only exceptions from this are the directives that are with the @ sign. So if I want to query anything from the model task, I would create the task.graphql file, and I would specify type query, which is the one of the 3 main types that GraphQL language offers. Query, as it states, is for receiving the data, for querying the data. So I would have essentially two, I guess, functions, tasks and task. And for one of them is that we want to query one task, and we would usually do it by ID. So that's how it's specified, and it's using the directive from the library for Lighthouse to find that. And as well, if I want to list all the tasks, I can make that request, and it's going to give it a directive of all. Second thing, which is mutations. As I said, this is for changing the data, so we can create, edit, or delete. Similarly, we can specify any sort of task input. So I guess the key takeaway here is that every time you create an input type, you fully specify that. So GraphQL has built-in validation, or essentially a type checking. So it's like TypeScript with SQL, with some extra, I guess, model binding, all together bunched up in this one very fancy language. So yeah, I think it's extremely cool, and yeah, I see great future and great use cases for most of the projects. There's hardly any limitation to that language. Yeah. If I go back to my slides, it's here. Cool. Another thing, Tailwind CSS. So again, don't know how many people heard of it, but it's this new fancy, I guess, CSS framework. How it works and what it does. I guess the key thing that you have to know about Tailwind CSS is that it allows you to style HTML without creating CSS files. And it sounds crazy, but it's sort of great. At first, I didn't know what to think of it. It felt weird, but essentially, the simplest way to describe it is that Tailwind CSS is doing inline styling. And the way I guess the one thing that Tailwind CSS does that inline styling doesn't do, and hence why Tailwind CSS even exists, is that the inline styling doesn't offer you the ability to style for responsive UIs. So there's no media query directives that you could put in inline styling. And that's sort of where, that's one of the key features of what Tailwind CSS lets you do. It's essentially a library of predefined CSS styles that you use, and you're gonna get extreme consistency across your UI. One other thing that I wanted to mention, that it's extremely small, 8.7 kilobytes for predefined CSS library. It's crazy small. Another great thing that was recently implemented, that perhaps if you heard of Tailwind CSS and consider using it before, it used to be huge. It used to be in excess of like 20 odd megabytes, a CSS file, because they did not have JIT, which is just-in-time compiler. Essentially, they now have it, and that's why your CSS files are going to be extremely small, because you're going to have only the definition of CSS classes that you only use for the particular example. And I guess the best way to show you is essentially this. So this is a simple example from the Tailwind CSS website, where they demonstrate this sort of basic UI. And as you can see, there's no CSS file. Everything is that Tailwind CSS library is included in here, and you have classes, and all of those classes are essentially predefined within the library itself. The one downside of Tailwind CSS, I guess, is it has a bit of a steep learning curve, because you have to figure out like their documentation is great, and it's very easy to find things around on the website. So it's just I guess at first, if you never use something like that, it's going to be like, okay, like what is px4? But you can, the cool thing is they have this tool, and it lets you know what px4 is. So px4 is the padding left, and the 4 is just a exponent. So it's essentially, it identifies a specific set of settings throughout any property they have in their library, or essentially framework, is that you can specify a specific number to almost any property, and it's going to be predefined. So usually they go from like 1 to 64. So it's going to be 1, 2, 3, 4, 5, and so on, right? And it's going to have a specific setting. In this case, px4 directs to 16 pixels. Now, if you're not you don't have to be limited by the constraints of the default framework. You can essentially specify your own defaults. So if you want your px1 or px4 to be default to padding left and right, for example, 2 pixels, because that's what your, the layout of the website you're coding requires by design, to match the design, you can totally do that. And then once you have your default file with all of the default margins and paddings created, then you just go in and you're always sitting with an HTML file or your Vue file. You never have to leave that file to style your entire page or entire website. If it was one page, you always in one file. You never have to jump back and forth between CSS file. You never have to worry about, should I be using left here, what positioning should be here. Essentially, all that is almost taken care of because most of it is now it's fully supporting grid, Flexbox, anything you need really. Like people are actually doing crazy cool things with it, and I think it's a fantastic tool. It's a bit weird. It looks a bit weird, but I guess the downside of it is some of the class lists are like super long, like here, and it might be a bit difficult to read at first. And but you can totally organize that. You can have mixins, or you can separate a specific UI element. So li would probably exist within its own, include file, especially if you're using, either React or Vue or Svelte. You just have those things sitting separate, almost be their own components, right? And then you can essentially create a master class that, for example, contains all of those classes. Obviously, there are some upsides and downsides and some rules of thumbs to follow. But in general, that's sort of what Tailwind CSS offers. And I do hope you like it. Cool. Few things to show around. So in here, I have a really quick example of how to integrate Inertia into one of the backend frameworks, and how it allows you to bind stuff. So it's extremely easy. So on the left, we have a Rails example. So you would have your standard controller. You have your events model, and you look it up by the param of ID. So if I had an URL with the events that I want to search for a specific event, and then your view binding happens, apologies, view happens through the inertia directive, which kicks in the entire library, and it will go to a specific view file whichever directory it sits under, and it will pass all the specific properties. In this case, the view will receive the ID, title, start date, and description. Equivalent of this is that in Laravel, if you're a PHP guy. Yeah, I guess I can jump in and show some of the more fancy stuff on the last few minutes of it in actual file. So in here, I have a basic test site that I started to build. It offers a few things: users, certificates, and contractors. Essentially, a contractor, user can issue a certificate for a given contractor, something like that, more or less. But yeah, let me jump into, for example, certificates controller. That's sort of the basic binding of it. You can ignore most of it, like through stuff, but what we can do here is we can specify different properties that get passed to the view file, which is like filters, and then I specify the object of certificates and any sort of certificate data or the relationships through that go there. And this would be my view. Same, likewise, the create action, that's sort of the binding you receive. So it maps through so certificates of drivers and contractors. So the relationship structuring is crazy cool as well. Validations on the store procedure, again, very, very, very cool. Yeah, and let me show you some of the examples of that. So again, I'm using Vue, and this is Vue 2. Vue 3 is slightly different, and a few things to cover on Vue. It generally uses Virtual DOM as well as React. I guess React is more JS based, while Vue is a bit more similar to AngularJS. It is similar to AngularJS because it uses its own directives. So, for example, we have we can use JSX in Vue, but we don't have to. We can use just normal own plain HTML, which is an example of here. The key here to note is that the text input is essentially a Vue component of text input, And some of the directive it offers is one of the examples is vModel. So it does that binding between the field and the field in the table in my database. So that's really as well, it kind of gets you going really quickly because it's almost no configuration needed, and it's plain and simple. You build your forms, field by field. You bind it directly to a specific field in the database if you want to. Yeah, it offers you the error handling. And again, I'm leveraging the Tailwind CSS to style some of those forms out. I guess as a final thing, I can demonstrate sort of how the app works, looks and works. If I jump to here. Cool. Okay. Should be all right. Cool. So that's sort of the demonstration app. The Ping CRM is the base that is available on GitHub, and it's available for both Rails and Laravel. So whichever you fancy, you can play around with. For Rails, I think the only example I found was with Vue. With Laravel, there were three of them. But yeah, it's again, the CSS is done with Tailwind. I can go to a specific record for a contractor, open it up, edit files. So if I compare it to edit on contractor, that's it. The key thing here is that likewise, where we have state in React, we have data sort of function in Vue, which is almost equivalent to the React state. So it keeps track of that for you. You have methods which you intercept. So any sort of action on form will be handled by Inertia through bindings such as @submit prevent on update. Again, if we just had normal action, it would just fire off. But because this is SPA, we want the Vue to handle that for us. And here is a quick demonstration of what data goes into that page. So we have auth, which makes sure for us that we are on the correct user. In this case, I'm not populating anything because I don't have that set up. And components, where was it? Here, layout, props. Here it is. Okay. Yeah, contractor. So my object contractor is receiving all of those props. I can play with them JavaScript side as I please in that form. Cool. Yeah, I think this is more or less what we have time for. 2 minutes left, so I will leave it for any sort of questions you guys have.